Hi, myself Saurabh Naskar, Assistant Professor of Chemistry at Gargi Memorial Institute of Technology. In my previous lecture, I discussed about second part of thermodynamics. Today I will discuss Carnot cycle and its efficiency. See, to have some work that is W, heat must be supplied, that is Q1, to the system or engine from the source at temperature T1, and some heat must be rejected, that is Q2, to the sink at temperature T2 by the engine. So heat engine means it can convert heat into work. If you giving heat in an engine, it will give work, and some amount of heat will be rejected in the sink. So here T1 is greater than T2 as heat flows from body at higher temperature to body at lower temperature. So T1 must be greater than this one. And this Q1 is heat taken up at temperature T1, this one. And Q2 is heat given out at temperature T2. This is given out at temperature T2. And W is work done by the engine. So here Q1 is heat given to the engine, and some amount of heat is utilized in performing the work, and rest of the heat is rejected to the sink. This is Q2. So we can write Q1 is equal to W plus Q2, this one. So W will be equal to Q1 minus Q2. Now we will calculate efficiency of engine by using the formula eta is equal to work done by the engine divided by heat taken up at temperature T1, that is Q1. So in place of W, we can write Q1 minus Q2, this one. So Q1 by Q1 will be 1 minus Q2 by Q1. This is the formula of heat engine efficiency. Eta is equal to 1 minus Q2 by Q1. Now we will discuss Carnot heat engine here. This is the most efficient engine, and it is also reversible engine. Here 4 processes will occur. This is the PV curve. This A to B means this process is isothermal expansion. B to C is reverse adiabatic expansion. C to D is isothermal compression, and D to A is adiabatic compression. See, here state A is changing to B, P1, V1 and T1. This state is P2, V2 as T2, T1. So pressure and volume is changing, but temperature is constant. So this process will be called isothermal process. And here see, volume is increasing. Volume is increasing in this way, and volume will be decreasing in this way. So in this process is isothermal expansion. Here isothermal means temperature will be constant, so change in temperature will be 0, and this internal energy is function of temperature. So when del T is equal to 0, then del U will be also equal to 0. From first law of thermodynamics, we can write Q is equal to W plus del U. So del U is 0, you will put 0 here, so the Q equal to W will be here. So Q will be equal to W. Now work done, the formula for work done in isothermal process is nRT ln V2 by V1. V2 means final volume, V1 means initial volume, and this is universal gas constant, this is mole, and this is temperature. So this is final, so V2 minus V1 will be there, and temperature is remain constant in this process, so temperature will be T1. So we can write W equal to Q, so we can write W1 equal to Q1. W1 means the work done in process 1. Now we will see work done in the process B to C. This is adiabatic expansion. Adiabatic process means no heat should be transferred between system and surrounding, so Q will be 0. And in adiabatic process, formula for work done is equal to nR T2 minus T1 by 1 minus gamma. Here T2 is final temperature, T1 is initial temperature. So see, in this process, this is final temperature, this is initial temperature. So you have to subtract T2 minus T1 here. And gamma is called Poisson ratio. This is equal to Cp by Cv. Cp is molar heat capacity at constant pressure, and this is molar heat capacity at constant volume. And here if you place Q is 0 in first law, this is 0, so W will be equal to minus of del U. So W is equal to minus of del U. This 2 means this is work done in process, second process, this is third process, and this is fourth process. Now we will see in third process, C to D. This process is isothermal compression. Isothermal means temperature constant, so del T will be 0, del T 0 will be, del T 0 means del U will be 0. And work done is equal to nR T2 ln V4 by V3. This is final volume, this is initial volume. So, and W is equal to Q here, because in isothermal process W is always equal to Q because del U is 0. So the work done in process 3 will be equal to nR T2 ln V4 by V3. And last process is D2A. This is adiabatic compression. In this process, adiabatic means Q will be 0, so W will be equal to del U, this one. And work done in adiabatic process is equal to nR final temperature minus initial temperature. Here final is T1, because see, in this process this is final temperature and this is initial temperature, because process is going from D to C, D to A. So nR T1 minus T2 by 1 minus gamma, this one. So we can calculate net work done by summation of all the 4 work done formula. This is W1, this is W2, this is W3, and this is W4. So net work done is W1 plus W2 plus W3 plus W4. And see, W2 and W4 will cancel out, because see here nR T2 minus T1 1 minus gamma, and here nR T1 minus T2 by 1 minus gamma. So if you take minus common, then the term will be here T2 minus T1, here also T2 minus T1. So this is minus of this one and this is plus of this one. So W2 and W4 will cancel out. So when we will summation all the work formula, then we will get this W1 plus W3, because W2 and W4 will cancel out. So this plus this. Now we know the formula for efficiency from this one. Eta is equal to W by Q1. So in place of W we have to write this one, and in place of Q1 you have to write this one, nR T1 ln V2 by V1. Now we will divide all the term by nR T1 ln V2 by V1. So if you divide ln T1 by ln T1 ln V2 by V1, these two will cancel out, one will be there. Here nR T2 ln V4 by V3 divided by nR T1 ln V2 by V1. So nR and nR will cancel out, T2 will be above, T1 will be below, and in the above ln V4 by V3 will be there, and in the below ln V2 by V1 will be there. And if you divide this one by nR T1 ln V2 by V1, there will be 1, so no need to write that. So again we can write, in place of ln V4 by V3 we can write ln V3 by V4 to the power inverse, this one. So this minus can come here, so we can write 1 minus this one. So you can write it equal to 1 minus this one. Again, in isothermal process, PV will be constant, and in adiabatic process, PV to the power gamma will be constant. So you can write, in case of 1, P1 V1 is equal to P2 V2, this one. In place of this one, adiabatic process, we can write P2 V2 to the power gamma is equal to P3 V3 to the power gamma, this one. This is isothermal process. Here we can write P3 V3 is equal to P4 V4, this one. And this is adiabatic process, we can write P4 V4 to the power gamma is equal to P1 V1 to the power gamma, this one. So if we multiply 1, 2 and 3, 4, this is 1, 2, 3 and 4, we will get a equation like this. Now see here, v2 to the power gamma, v2 to the power 1. So if if v2 comes in this side, so you can write v2 gamma minus 1, this one. v4 to the power gamma, v4 to the power 1. If v4 comes in this side, so you can write v4 gamma minus 1 in this way. v3 gamma minus 1 and v1 gamma minus 1. So all gamma minus 1 will cancel. So we can write v2 v4 is equal to v3 v1, or v2 by v1 equal to v3 by v4. So in place of v2 by v1, we can write v3 by v4. So in place of v2 by v1, if you write v3 by v4, then these two will cancel out. So final equation will be eta is equal to 1 minus T2 by T1. This one, 1 minus T2 by T1, or you can write 1 minus Q2 by Q1 from this side, this one. So efficiency of engine will be 1 minus T2 by T1 equal to 1 minus Q2 by Q1. You have to remember this one. Now Q1 minus Q2 must be less than Q1, because Q1 is heat given to the system and this is heat given out in the sink. So, and this Q1 minus Q2 is equal to W. See here, this Q1 minus Q2 is equal to W. So we can write W is less than Q1. So in the formula of efficiency, we have Q1 minus Q2 by Q1. So this is W and this is Q1. So this should be less than 1, and this is means eta. Eta means efficiency. So efficiency should be less than 1. So always remember, 100% conversion is not possible. In my next lecture, I will discuss entropy. Thank you.